Welcome back to CodinGame Fall Challenge 2024. So there's only a couple of days left for this. I don't think I'm going to be spending that much time on it, to be honest. But I will aim to get 100% here, which means 100% of the test cases passed. I think that's a reasonable milestone, and I don't think that should be difficult. So, you know, I could probably do it in a few lines. It really just depends what. Well, with my current strategy, I think is just build random, iterate over the landing pads, and iterate over the destinations, and just every time you can build a track from one to the other, you do so. That's not very good. So I reckon instead, what we should do is just look at all the landing pads, check what citizens are arriving, and iterate over all the modules and check if they match the citizens, and just pick the link between landing pad and module. Just pick one of them which maximizes like the number of people that can reach that destination. That should get you points, and also you want to make sure they're affordable. So okay, we go through every pair X, Y, where X is a landing pad and Y is a module. We check if there are people at that landing pad who want to go to that destination. We check, can we afford to buy this link? And basically, over all those pairs, we choose the one which maximizes the number of people, because that's basically how many points you get. For each astronaut, like, we'll basically get 50 points if we bring them to that place. we won't get any balancing points, or at least we'll probably get declining balancing points. But it still won't be too bad. And like in this distribution network here, this one is the tough one because
you've got all these astronauts, 9, 10, 11. But these buildings,
they don't want to go to these buildings. They want to go to these places. So is there really any reason to build links to these? I don't think so. So it's kind of a trap. Like, why wouldn't you build a link straight to the end? Well, because you can't afford it at first. You got 6,000. And how much does it cost? One for each, so it's 10 for each kilometer. And we're trying to go roughly like 100 kilometers.
or a bit more.
So it costs somewhere between 1,000 to a few thousand. We can afford one link at least to one of their destinations. So we should be getting points on this one. I mean, not right now, but we should be able to get points on this one. So, basically we scrap this. So we know how much money we have, don't we? Yeah, we have resources. Sorry, no, we don't scrap this, we scrap this. Okay, so we know the landing pads and we know the modules. That's just this loop here. So this loop here we want to scrap because that's very arbitrary. Or at least we do iterate over them, so we go like here. Let's just pass. Just make sure this doesn't time out. Because there's a lot to iterate over. Okay, we don't time out, good. So, hello, Concombre des Oceans. Concombre, is that guinea pig? Concombre? Is that some sort of animal? Hello, my friends. Can you send me your code or try to optimize it? Your logic seems interesting. After the competition is over, yeah, I can send you a link to the code. I can't do it while the competition's running just because it might break some rules. We're not allowed to share code directly while the competition is live. But yeah, I can message you in Twitch after this is all over. If I forget, you can remind me in Twitch Whisper. Alright, so let's see. I want to... Okay, so for a landing pad and a module, first we want to measure the distance. Because if we can't afford it, then there's no point building it, right? So... So we want to reserve 1,000 resources to actually build a pod. There's no point building a link if we're not going to add a pod to it. Because there's no reason to do that. You can just save it and do it next time with a pod. So we'll reserve 1,000 resources. So basically we need our resources minus 1,000. That's our pool, our budget for building trains. We could try to build one. Alright, so we want to find the distance between two buildings. This is Euclidean distance, isn't it? Alright, so probably want Euclidean distance. Turn self dot x minus other dot x squared plus self dot y minus other dot y squared dot square root that should be the distance. So cost equals, so it's going to be b1 dot pos dot dist b2 dot pos. So is that how we did it? Yeah. So that should be the distance, but multiply by 10. Each one costs one resource for each 0.1 kilometers of tube installed rounded down. We want to be precise here because we don't want to buy something if we can't afford it. So it's actually, you count how many 100-meter blocks there are. So I think what we do is that's the number of kilometers, the exact number of kilometers. We multiply by 10. That gets us the number of 100-meter sections, 0.1 kilometers. Then we have to round it down. So do int of that. So that's going to be a float. So that tells us how many full 100-meter sections there are. And that number there is how many resources we spend. I assume that's what this sentence means. So if cost is greater, cost plus the 1,000 it takes for the pod is greater than city dot resources, then we skip this. Right, so we only look at the ones we can afford. Also, we need to make sure that there's people in this city that actually want to go to this destination. Otherwise, we're not interested in this thing. So we want to say... So how does this work? For astronauts. I'm gonna look at this again. It could be duplicates. Okay, I see. So if we do... If E2 dot, so we look at the module type. If it's not in our astronauts list, hello Brad, E1.astronaut, then that means there's no astronaut wanting to go to this module, so we'll just skip this one. So we're only just focused on the ones that we have astronauts. All right, let's try this. Like we can add some optimization here, pick the one with the highest number of astronauts or something. But right now we've found a feasible link between a landing pad and a module that we can afford and have 1,000 to spare after we buy it. And there is at least one astronaut who wants to go to this place. So in theory, this should get us points. And there's always going to be a pair like this, aren't there? Because by definition, there's always going to be a landing pad and a place where an astronaut wants to go to that place. The only thing is we might not be able to afford it. But like if we leave the game running, maybe the interest will give us... Yeah, I mean, look how much resources we have if we just let the interest accumulate. Yeah, so we'll always be able to afford one. So this should work. This should pass the test cases, unless I've misunderstood something. So, need an advice from you. I keep getting timeout for several test cases. My string for the command keeps concatenating. Do you have an idea what can I do? So have you looked at how long your string of orders is? Like, because I was timing out the other day, and that was basically because I was doing kind of a quadratic number of orders, because I was going through every pair of buildings and trying to build a link between them, even when I couldn't afford it. And I don't know if that was exactly what caused the timeout, though, so I'm not actually sure what. But yeah, but for like these buildings, quadratic number would be 100 times 100, which is like 10,000. So there'd be like 10,000 pairs, which still isn't too bad, but yeah, when you're concatenating them all in a string, I guess that actually could take up a lot of time. So I'm not sure what the problem is in your case, but you could like cap your list of orders to be like never more than 20 or something. I don't know. The command creates tube that already exists, and when I don't have the resources, yeah. So what I'm doing now is I'm doing a resource check. I'm only building stuff I can afford. But you can also check if the tube already exists, because it should be in your city tubes list. Well, that's a point. I should check that as well. So when Right, so tubes. Okay, so my city tubes, that shouldn't be a set. That should be a dictionary. Which maps a pair of buildings, well, no, a pair of building ID numbers to an int, which is the capacity. Does having a timeout for one test case stop another test cases to run? No, because you can run them independently. But when you press play all test cases, yeah, it stops as soon as it hits an error. But you can manually run the later test cases just by clicking these buttons here if you wanted to. But when you submit it, yeah. No, when you submit it, it does try all test cases. Even if ones fail, it still tries the later ones. Yeah, because that's how you get your percentage. So we've got 2, 1. Alright, so now we're putting the tubes in like that. So if we want to check if a tube exists, we want to skip it. So I hope you verify if the tube exists before creating it, as I'm getting errors when trying to do so. I want to see how you do it to have an idea. Okay, that's what I'm doing right now. So the way I've done it, if I want to check if a tube exists, I say if the tuple b1, b2 in going to be city.tubes, because this is the dictionary. That's it. B1, B2 would be in the dictionary somewhere, and B2, B1 would also be in the dictionary somewhere, because whenever I add it, I add them both ways around. And I don't care about the capacity right now. But yeah, the key should be the tuple. I mean, if I don't care about the capacity, I could just do it like teleporters, so just be a set tuple int, but I'll store the capacity as well because I might use it later. So I'll make a note here. Check if tube already exists. Check if can afford with 1000 left for pod. Check if have astronaut wanting to go to B2. If all these are true, it's only a warning when the tube already exists, right? Yeah, but it will affect my logic here because normally when I build a tube, I might want to stop or deduct the cost for my resources so I know how much budget left I have for more tubes. So probably for now I just want to stop, just build one tube. But there's no harm really in doing that, except you might time out if you're doing too many, which seems to be what was happening for myself and Brad here. So yeah, if you're scanning through a quadratic number of pairs and building tubes, well, no, scanning through a quadratic number of pairs is the problem in itself. So yeah, building tubes where they already exist might not be that big deal, but yeah, for the purpose of my logic, it's best to avoid it. Plus, I'm going to build a pod when I build the tubes. So if all these are true, that means we're good to go. We'll build the tubes. Okay, so we do... So we make a tube. And then we make the pod. And we'll make it go B1 to B2 and back to B1. Nice and simple. Oh. Well, that's another thing. If we don't have an ID number available for it, then there's no point building this tube because we won't be able to even build a pod for it. Check if have available pod ID. I mean, when that happens, we just can't build any more pods, can we? Unless we destroy old ones, which haven't really got any logic for. But if not available pod IDs, continue. All right, now we do this. Okay, so, and then what we could do here is try to build multiple tubes in one turn. That might, as long as we deduct our resources. So if we choose to do this, then we can say city.resources minus equal, it's going to be the cost, the kilometer cost, plus 1,000 for the pod. And then we could go to the next loop and actually try to build other tubes in one turn. Why not? It's not much harm in doing that. So this is not optimizing, it's not choosing the best route, it's just choosing any tubes which should get someone straight to their destination. In some cases, there may not exist many such routes, but we can do that. And we'll keep doing that until we run out of money. Why not? Let's try it. Let's try it on the base example to begin with. Or just try with test cases. Ah, it's frozen. Which is correct behavior, but we kind of want to modify it. Okay, then what we should do is, that's good. It's stopping us from doing something unsafe. So what we should do is create temp resources equals city.resources. And this is like, because the ground truth is this, that's fixed and not going to change. That's how many resources we have. But we can say we're modifying this one. We're assuming that we actually can afford these things. So we'll modify that and then just use that. Try again then. Where's this error? And why is it still running? Hang on, okay. City.troops set object does not apply. So I should have changed that to when I initialize city, hang on. Looks like we might actually pass all test cases, but there's something weird going on. So it's printing an error, but it's also continuing because it has some default handling. Where is start? Okay, I'll just wait for all this to run. Okay, we passed all test cases. This should be 100%. But I need to fix this. So city.troops. So when we initialize, here we are. City equals there's a warning here. That should be an empty dictionary. Okay, just try it again on, say, the last one. So let's look visually. Oh, look, see, that's nice. We're sending people to those two. This should get us decent points as well, because we're actually trying to get points this time. And as our money goes up, we can actually afford. But why aren't we building anymore? Like, we've got loads of money. There's astronauts here and here that want to go to places. For B1 in landing pads. These are all landing pads, right? Yeah. The B2 in modules. I think because we ran out of pods, maybe? I don't know, we could, Oh, we've got a lot of warnings. Tube already exists between... Alright, so this shouldn't be happening now. We're supposed to be not doing that, and that's causing... That is actually causing a flaw in our logic. Also, I just remembered that a building is only allowed to have, what, 5 tubes coming out of it? And we're not accounting for that. But that could be the reason. But why is this happening? 121 and 113. Ah. Using the ID nums. Not, those are classes, those are objects. Okay, try again now. Maybe we'll get more links. Okay, we stopped trying to build links where they already exist, but we're getting a different warning. Could not create tube between buildings 122, 111. It intersects the existing tube between 121 and 113. Wait, what? Intersecting? That's a thing? Oh my god, I forgot. Are they not allowed to intersect? It doesn't say that. What? Could not tube between... Intersects the existing tube between 121 and 113. Oh, it does, in bold. I ignored the bit that was in bold here. 2 tubes cannot cross each other. Well, this changes things. And that's why they give us that geometry stuff. Okay. So what we should be doing is checking all this stuff. There is another thing we could do though. We could randomize landing pads. Maybe even randomize the order of modules. That means we won't get stuck on the same thing every time. We'll just be trying different points and hopefully we'll find ones that don't cross, although they'll very often cross, but that's the point of these. It helps avoid the crossingness. So what was the... How many points did we get here? 86355. 86355. So I reckon if we shuffle this, then we'll allow for better links. So if we do that, random dot Random dot shuffle? Is that the right one? Yeah, shuffle it in place. Shuffle both of these. So that we don't get stuck on the same one every time. Now try again. So we want to beat 86,000. This should beat it because every now and then we'll find a link which works. Huh? It's worse, but also it doesn't look like it's shuffling. I think it just can't build the other ones because they're all crossing. So early on, there were only these two. That's why this happened. But if we rerun it, we get different randomness, don't we? So interesting. Okay, so it's easy to get a few points, but to actually hook these all up is very difficult because you actually got to integrate this network into it, these intermediate nodes. That's how you're supposed to do it. That is pretty tough. I don't think I can even do that within the next 2 days, so I think really we're just trying to grab some easy points here. Intersection is the big problem. We could write some intersecting code just to avoid placing this, and then we might end up placing some other ones. But shuffling is probably a good idea. Do we ever get another one of these? It's always the same. Let's try some other one. I want to see that the shuffling is actually doing something. I want to try one where the building's just fixed. Then it should shuffle. Look at that. That's beautiful.
That looks like we could be getting some good points out of that one. Way better than what we were doing before. Alright, so that's what it looks like. So you got like a few lines here. Now if I redo this one,
hopefully it should be different. That'll mean we're shuffling. Kind of looks the same. Wait, what did we get? I've got 148,000 points. If the points are different, that means we shuffled, because that's the only thought of RNG, right? 48,000. Yeah, it's different. Okay, fine. It's shuffling. It's just it's picking those because those are good routes. All right, let's just do one more little test case and nothing else. Submit this. This should get us into the top like 200 or 300 or so because there's only 200 or 300 people who have passed the test cases. It seems. But I can think of some good ways to improve this now. And this might be the last stream I do of this, because I don't like to actually get into a good solution. I don't think I have the time. Yeah, it looks like it's working, so... Man, I'm quite hungry now. Haha, see, that's so much better now than what I was doing before. The randomness does actually help. I mean, that's one thing I learned from studying optimization at university. Like, you can do a lot of good things with randomness, because randomness avoids a lot of the bias of determinism. It's just one of the downsides of randomness is it makes it hard to debug, because you don't know what caused an error. If you got to make sure you use the same seed. All right, submit it then. Alright, so we got past the test cases, so we got 100%. That's what we wanted. Got 2.5 million, so that's an improvement over last time, which was 1 million. There we go. Rank 337. Okay, so lower than I expected, but that's because more people now have passed the test cases. That was to be expected anyway. Okay, so I think the next thing that'd be really good to do is to avoid these crossings, because we're just trying to build things where we actually can't because it crosses. Now this... This will be tricky. Not really. I mean, they've already given us the code for the crossing. We just need to write the for loop, really. Segment, segment, intersection. So we just have to turn this to Python for one thing. That's probably not too hard. It's already... What language is this anyway? Just copy and paste that for now. Put that after pause. So define orientation. So that's 3 pauses. So B prod equals p3.y minus p1.y times that times that minus that times that. This is cross product or something, isn't it? I don't remember my geometry. Okay, so that's fine. Return the sign. So it's -1 if it's negative, 0 if it's 0, and 1 if it's positive. Do we have a Python method like that? Or do we just have to say just define sign of x, just, I don't know, z. If z greater than 0, return 1, elif z less than 0, return -1, return 0 otherwise. And then this one, return, so it's orientation that times orientation, so it's, so we want that times that to be less than 0, and we want that times that to be less than 0. Alright, if I just trust this code, you just have to plug in the 4 points to get the segment to get true if they intersect. So now we can say here excuse me. If any hang on. So we're intersecting. So A and B are going to be the points. So it's going to be B1 dot pause, B2 dot pause. And then this could be C dot, I don't know, B3 dot pause, B4 dot pause, for B3, B4 in city dot tubes dot city dot tubes. That just checks all the keys. And for every key, it'll do the geometry. So if any of those, that might take a while to run, but it's only running through existing tubes, which is not many, so continue. Alright, let's try that. Hopefully, we won't get any more intersections now. But we might get intersections with them if we run this for loop. If we try to add new tubes, they might intersect with the ones exist. But the first tube we place shouldn't intersect. So we might get some interesting results. What happened here? Ah. This is wrong. B3 is an ID num. So we need buildings. That's like city dot buildings B3. That gets the actual building. Try again. So now we're getting, let's try nested layers. $350,000? That's better, isn't it? I don't know. So it's avoiding intersections and what's going on here? Oh, it's because we're not accounting for the maximum number of tubes a building can have. That's another thing we need to check. We should do that as well. So when you have a building, we need a method. Get num tubes for a building. We return sum. So we just want to say building in tube for tube in tubes. So for every tube, we check if that building is part of that tube, either the beginning in okay. Segments is the last thing you want to do because it's the most expensive operation. Could do this one early. Oh, no, we'll do this one here. So if city.num get num tubes, B1 equals 5, or I don't know, greater than 5, or five, right? It's the max. 5, yeah. Alright, let's try that. Now, it'll still happen if we're building many tubes per turn, but it's less likely. Yeah, an improvement. How about the final one? Are we ever going to get out of this, though? Why can't we do any others? I think it's because...
Well, I think they did this on purpose. I think these guys want to go to these ones. Yeah, these guys want to go to these ones. So, fortunately, these guys in the middle want to go to these ones. So you can never actually get them across if you place those. So, this is a trap. The moment you place one of these tubes, you've now basically blocked these off from ever being able to get... Unless you place teleporters. In fact, why don't we have any teleporter code? We've got enough money here to build teleporters. So after we do a pass here, we should then do a teleporter run. Yeah, we should do that, shouldn't we? Well, we can try submitting this now. So 2.5 million is what we got. Okay, we improved. About 4 million. So that avoids trying to build, so it can still happen if we're building more in one turn, but that's pretty good so far.
We're in the top 200 now. Alright, so I reckon we just place teleporters, because that will actually do well for this distribution network where we've got lots of money, but we can't do anything about these. So it shouldn't harm us to now, after this for loop is finished, we just try to build teleporters. I mean, there's no reason not to just do it at every pair, right? So we can just do, and don't care about the cost at this point. So we say, we still do some of these checks. So we want to see, check if teleporter doesn't already exist. We don't care about the cost because we're not keeping accurate check of the cost at this point. We do want the astronaut thing though. So we basically want, we don't care about the, whoa, this will be, check if teleporter doesn't already exist. Don't care whether we can afford it. We do check if there's astronauts between those two. Right, so how do we check? So we check. So if there's a teleporter coming backwards, I can't see how that could ever happen, but if there was, then we also wouldn't want to build it, but I mean, that can't really happen, can it? We can check for it anyway, just in case. Because it can't build a teleporter where there already exists one, even if it's coming the other way, I guess. Because it can either be an entrance or an exit. Can you do a two-way teleporter? Each building can only accommodate a teleporter entrance or exit. Okay, so you can't do two-way. That's fine. So we'll make sure we go from 1 to 2. Okay, so at this point we just build it. We just say orders.append teleporter. Is that the text? Teleport. We'll make sure 1 to 2. Okay, because if it's 2 to 1, then we're basically wasted. Right, let's try that on distribution network. That should change things dramatically. Because we get so many resources, we'll just plop lots of teleporters down. Not enough resources, okay, fine. But now we're getting resources. Look, we're spending all our resources on teleporters. Could not create teleporter. Building 1, 2, 3 already has a teleporter entrance or exit. Why is that happening? Well, anyway. Oh, we get way more points on that one. Why are we building... I think because we've got... No, we shouldn't be trying to build teleporters where there already exists. Oh! It's not, this is not... What matters is whether the entrance or the exit is there. So if the exit is in the destination, that's fine. It can probably receive from multiple different teleporters. But... if we to find a teleporting path, are you allowed to have some other building also teleport to that same exit? Well, either way, so we want to check. So we really only care about the entrance right now. If any e1.id num in teleporter for teleporter in city.teleporters continue. So if we already have an entrance at B1, because that's what it's complaining about. Try again. So I think we can share exits. I don't know. Not create already has a building 107 already has. 107 is on which side? Ah, you can't share exits. Okay, so all right, if any or basically what we're saying is if any or B2. Okay, try again. So it's only complaining about not enough resources. That's fine. But we do end up getting teleporters between basically every building. So that gets us points. That's good. Make sure that works. That should work. So that's an improvement. So we now got tubes and teleporters. That's the two different things we can build. The other things I've not accounted for are upgrading. We could throw that in somewhere. But if I'm doing everything that they're offering us, then that's already a decent solution. It's still very. Keeps resetting my positions. What am I looking for here? City construction part. Here. Yeah, here. So we can build a tube, we can upgrade, we can teleport, we can place a pod. So we've done all of those things except for upgrade. So we should probably do a run where we just go through, like, after we do all that, then just try to upgrade every tube. Like, if we have money left over after we do all that, then might as well. Like, oh, grid failed. Timeout? Oh no. That's not good. Ooh. We're trying to connect 38 to everything. So we gotta... Damn. That's another pitfall. So we can put a hack in and say the moment we build a tube from this landing pad, we don't do this landing pad again. We move on to the next one, just to spread things out a bit. So we say if we've chosen to build something, then go to the next landing pad. Break. And we can do the same here. All right, now try that one. That should stop trying to pile too many tubes onto one node. That wasn't the precise source of the problem though, but okay, that's good. Look at that, it's a very plainer set of lines. All right, should we just submit that then? And then we can add upgrade code. Well, that was better. 126. Wow. I'm kind of ready to call this a day and maybe come back to this in the future, but I'm not sure. But let's add this upgrade code then. So, should we just try to upgrade every tube? So at this point, we can now go for tube. So it's going to be for B1, B2 in tubes, in city.tubes. That should get every tube. Let's have a look. Just try and upgrade it. No. There's no harm in doing this if we have money left over, really. Up. So it's going to be upgrade B1, B2. That's just not the ones we've just built, but the ones we know exist. All right, let's try that. See if we beat 4.2 million. Oh, stop. Stop, stop, stop. It's the B1. Ah, this is wrong. Stop, stop, stop. Stop. That was an ID num. So now we just, if we've got nothing else to do, we just upgrade. Why not? This one we don't manage to do much, but we do get teleporters at least. So when in doubt, just put teleporters down. We're spending all our money, which is good. An argument could be made for holding on to money so you get interest, because it's not clear to me where you even get money from other than interest. I mean, getting points, getting tubes down early means you'll get points for the rest of the game from that tube. Because those citizens will just keep arriving, so... That's pretty nice. So we had no money. Looks like if you've got no money, then you just have no money forever. So maybe there's an argument for holding on to money so that you can get more money. I don't know.
Clusters. This one's crazy. What? I can't even see what's going on there. Distribution network, it's a trap, but it's really hard to spot that trap because this is what it looks like, right? Now, from the perspective of the code, it doesn't know that these nodes will never have astronauts going to them. Like, we just see the map, we don't know what to do with that. And it doesn't know that there'll be more buildings to come. It doesn't know. So it says, okay, well, these buildings will go to here, and that's the right choice, but then it completely blocks off on what can happen next. I guess you're not really, in this, to do well in this challenge, you're not really supposed to do well on the general case. You're supposed to do well on these 12 types of maps. So the real test case is not this, but similar to this. So really, like the top people, they're actually identifying, is this, they're looking at the input and they're saying, this is probably distribution network test case, and then use special code, which is written for distribution network, to account for that. So they're probably just identifying which of these 12 different test cases it belongs to, and then using special code which optimizes for that particular test case. And that's the smart way to do this. Let's try submitting that. No way would I bother to go down that path. But that's really what you need to do. Oh, my score went down. A lot. It doesn't like me upgrading. I mean, it could be because of the randomness though, but I can... Best score. How does it work? Will they just use my best? So upgrading dropped my score down.
Try submitting again just to see if it was a bit of randomness, but otherwise we just go back to not upgrading, but that's a bit strange. Like, it shouldn't really harm you, but then I guess it's removing funds for next turn. Yeah, I think teleporting, it wants to have the money spare to teleport. And so upgrading is removing all my money, and then I have nothing left to gain interest on. That's what's happening, I guess. So ideally we leave money. How do we even do that? Is upgrading really worth it? Maybe we're just wasting money because there's some cases where we're not getting enough. So it increases the capacity by 1. The initial capacity is what, 1? Oh, but we're not using the upgrade. The upgrade increases the number of pods you can have, but we're not doing anything with the pods, so that's just flat wasting money. Ah. That's the issue. Yeah, don't do that. Like, the only safe way to do it would be to add a pod the moment we do it, but that means we need to check whether we have funds. So we'll need to be accurately checking our funds the whole way. We can do that though, but alright, just go back to this then. No upgrading, because there's no point upgrading if you're not going to add more pods. You're upgrading so that you can have more pods. So just go back to this submission without upgrades. That means the passengers will still get to their destination. They just have to wait for the next, wait for the pod to come back. So we just lose a bit of time points. It's still good. Oh, that was our best yet. But does this matter? Like, which code are they going to use for the final submission after this is over? Get into the top 100, but we need to check how this works. Oh, do they have a explanation? What's gonna actually happen? I think I'll do that offline. I'll look into this because this doesn't matter. I think they're gonna just rerun everything with a different set of test cases. So these points are just a rough indication of what you might get. I don't know. Yay, I'm the best in Amazon. Best in Cambridge. DBDR is 16. Yeah, DBDR is a very strong competitor. Well, I'm pretty happy with this at the moment. We'll just leave it like that. If I do another day, could do it tomorrow or the day after if I feel like it.
It was a good score, top 10% or so. All right. Yeah, this upgrading thing, I should, like, it wouldn't be too much work to just handle the costs correctly, and then when I upgrade, I add a pod. If you've got 1,000 to spare. Otherwise, don't upgrade, because you're just wasting money. If I do that, that might actually be good. But remember, this cost, it's 1,000 per pod. The upgrade costs about 1 to 2,000, maybe more. At that point, it's almost the cost of a teleporter. So it is important to get all the teleporters in first, because they give you instantaneous, so they're getting you good points. And I mean, it's the later upgrades here are almost as expensive. So yeah, do all the teleporting first. And I need to figure out money, because I think you need to leave yourself some money so that you get money. That's your only source of income, which is weird. So like, I think we want to always leave like, how much would we all want to leave? Like, if we always want to be able to pay, so that's 100 kilometers. So in general, one of these tubes costs I mean, it'd be nice to leave about, so when we get to 5, for example, what happens next turn? Then we suddenly get, all right, so the interest happens, but you also seem to get income. But we don't know what income you get. It might differ between test cases, so if you get income, then the interest isn't that big a deal. Yeah, okay. Well, anyway, next time we can maybe upgrade things. We can try submitting a couple of times just for the RNG, see if we can get a higher thing. Not that it won't really affect our final competition score, but it would be funny. Before, just rerun one more time, go on. All right, but I think I'm done. Is anyone else doing this? I don't think this is as popular this year, or this season. Went down a bit. I don't think they'll like me submitting too many times though, so CodinGame. Nope, it's just me. Okay. Alright. So it probably won't be the last stream. I'll probably do one more in the final day, or maybe tomorrow, I don't know. Well, that was a very productive session. I mean, I basically shot up from 600 to 700 or so. Where did I start? To top 150. Okay. All right. Thanks for watching, and see you for what will probably be the last session for this challenge. So see you next time. Bye bye.